Hey guys, here we're going to start going over the linear algebra section of engineering math. So we're going to start with row echelon. Now to start, row echelon means that it looks like this, and squigglies just represent any number. So what row echelon means is that the first number in every column, in every row, is a 1. So this would be kind of like row epsilon. So what we want is to get it in this format. It doesn't matter what these squigglies are. All we want is to make sure that the first one in each row is a number 1, just like these three are. And everything underneath it has to be a 0. So these have to be 0 and this has to be 0. Alright, so let's get started. First we're going to write this as a matrix. So it's going to be a 3, -2, 1, and then a line. This separates the values from the answer. So the answer column is always to the right of the line. -2, 2, -1, -2, 1, -1, 1, -1. Alright, so there we go. That's that. And from here we're going to start matrix, doing some matrix manipulation. Now, what does that even mean? You can add rows together, you can subtract them, you can multiply by a value and then add them to get to do things. Now, as long as you don't break math, you'll be fine. So here, let's look at what we can do. So this one's already a 1, so I'm gonna just make that my row 1. Real simple. So now this is -1. So the rows always stick together. So I have to keep them together. Now the rest, you can either shift them down or you can switch them. Actually, this probably makes more sense since I said I was going to switch them, so just switch them and leave this here. Now, I want these to be 0, so that's what we're going to work on first. So we're going to do something along the lines of 2 row 1 plus row 2 equals row 2. So what that means is that I'm going to multiply row 1 by 2, add it to row 2, and we're going to make that our new row 2. As long as you don't break math, you'll be fine. So here we get, well, this one stays the same because we haven't changed anything about it. Now multiply by 2, so 2 minus 2 is 0, which is what we're trying to do. We're trying to get a 0 here, so perfect. Now let's do the rest of them. So that'd be -2 plus a 2 is 0. And 2 minus 1 is a 1. And then -2 plus a -2 is a -4. So now we're left with, wow, I did something wrong here. Yep. I rewrote the third row instead of switching it, so this should be a 3, -2, 1, 1. Awesome. My bad, guys. Alright, so now we're going to do, this is going to be left the same. And now we want this to be 0. So we're going to do -3 row 1 plus row 3 equals row 3. So we're always going to use that first column, first row, to start canceling the 0 to make these 0, these two 0. Okay, so let me zoom out. Maybe we can do a little more work on just this sheet. So here we're left with, everything else stays the same. 0, 0, 1, -4. In this case, -3 plus 3 is 0, and it's going to be 3 plus a -2 is a 1, and a -3 plus a 1 is a -2, and a 3 plus a 1 is a 4. So now, as you can see, it's pretty much row epsilon. It's just that this one, if we switch 2 and 3, we're going to be in row epsilon form. So 1, -1, 1, -1, 0, 1, -2, 4, and 0, 0, 1, -4. So what does that mean now? This column is our x column, this column is our y column, this column is our z column, this is our answer. So what that means is we can plug it in. So 0x plus 0y plus z equals -4, so z equals -4. Then we have y minus 2z equals 4, or y equals 2z plus 4. Plugging in our z, we know this is going to be -8 plus 4 is -4, which equals -4. And now we know x minus y plus z equals -1, or x equals y minus z minus 1. Plug in our stuff, we're left with -4 plus 4, they cancel out, minus 1, this is -1. So those are our solutions. X equals -1, y equals 4, z equals -4. It's a lot simpler than trying to solve here in the original. You would have had to solve for x in one of them, plug it into the other one, then solve for y in that one, and plug it into the last one. Something very finicky like that. Alright, let's do another 3x3. So here we're going to write it as our augmented matrix. This is what this matrix is called, by the way, when you put it into a matrix with an answer column. It's called the augmented matrix. 1, 1, 1, 1, -1. Alright, so we have our 1 on the top corner, so that's we don't need to change anything. Now we want to make these 0. So what we're going to do is we're going to do row 1 plus row 2 equals row 2. So we're going to end up with 1, 2, 1, 1. Stays the same. So 2 minus 2 is 0. 4 minus 2 is 2. And then 2 minus 1 is 1. And then 2 minus 1 is 1. This row will stay the same. Keep in mind you can do multiple operations at once. I'm just showing just one operation at once, just because it probably make our life easier. Just so y'all can learn, but once y'all have the hang of it, you can for sure do multiple things at once. So here we go, 1, 2, 1, 1, 0, 2, 1, 1. And here we do row 1 minus row 3, so 1 minus 1 is 0, 2 minus 1 is 1, and 1 minus 1 is 0, and 1 minus a -1 is 2. So as you can tell, we're almost at row epsilon. Since this is a 0, I'm just going to go ahead and swap these two rows, make my life a little easier in the math wise. This is 0, 1, 0, 2, 0, 2, 1, 1. Now we want this guy to be 0, so we're going to do -2 row 2 plus row 3 equals row 3. We're left with 1, 0, 0, 2, 1, 1, 0, 2. Alright, so then -2 plus 2 is 0. -0 plus 1 is 1. And -4 plus 1 is -3. So that means that z has to be -3 from the last row, and then y has to be 2, and x plus 2y plus z equals 1, or x equals 1 minus 2y minus z. Plugging in our y and our z, we're going to be left with plus 3 minus 4, so it's going to be x equals 0. That's our system. Now that's if you have 3 equations and 3 unknowns. So, and they're all independent. Well, that's just a lot of fancy words for saying that there's a unique solution. There's only one solution to that system. So now we have 4 unknowns, but only 3 equations. So if we write our augmented matrix, it'll look like this: 1, 2, -2, -1, -1, -2, -5, 3, 1, 2, -1, -3, 2, -2, 1. Now, if you write it, like if you notice, we have less rows than we have columns. That is Um, that means that there's not enough equations to solve this system as a unique solution, but we can still solve it. There's just infinitely many solutions. So what we'll do here is we'll start row reducing, getting to row echelon form. Now keep in mind, like I said before, just the first number in each row has to be a 1. Everything left of that has to be 0. So that means that I'll show you kind of what that includes. So now this is a 1, so that's a check, we're good. Now we want to make these two 0. So we're going to do row 2, row 1 plus row 2 equals row 2. We're left with 1, 2, negative 2, negative 1, negative 1. And then 2 minus 2 is 0. 4 minus 5 is negative 1. And then negative 4 minus plus 3 is negative 1. And then negative 2 plus 1 is negative 1. Negative 2 plus 2 is 0. And then this will all stay the same. Now we want this guy to be 0, so we're going to do row 1 plus row 3 equals row 3. So now we're left with 1, 2, negative 2, negative 1, negative 1, 0. I'm going to multiply by a negative just to make our numbers look a little nicer. We're going to have 1 plus a negative 1 is 0, 2 plus a negative 3 is negative 1, 2 plus a negative 2 is 0, 1 plus a negative 1 plus a negative 2 is a negative 3, and then negative 1 plus a 1 is 0. Now to make this a 0, we're going to just do row 2 plus row 3 equals row 3. We're left with 1, 2, negative 2, negative 1, negative 1, 0, 1, 1, 1, 0. And this is left us with 0. 1 plus a negative 1 is 0. 1 plus a 1, 0 is 1. 1 plus a negative 2 is negative. Negative 3 is negative 2. And 0. So we're left is with z plus or minus 2w equals 0, or z equals 2w. Now since we don't have enough equations, we're gonna have to make one of these variables arbitrary or any number. So we'll just make w in this case arbitrary, and we'll make it equal to a variable t. So now we have to solve everything in terms of t. So this means that z is going to be 2t, and now we see that y plus z plus w equals 0, or y equals negative z plus minus w. Plugging that in, we're left with negative z, which is negative 2t, minus t is negative 3t. And now we're left with x plus 2y minus 2z minus w equals negative 1, or x equals negative 1 minus 2y plus 2z plus w. Plugging in all that, we're left with x equals negative 1, negative 2y, it's going to be 6t, plus 6t, plus 4t, plus t, which is negative 1, plus 11t. And so now we have an equation for x, y, z, and w. And that's row epsilon. Matrix multiplication, that's another thing that's going to be covered in this exam. And the main thing about this is to understand how matrices are multiplied together. So now if we look at this question, D equals A times B minus 4c. So when you have a scalar or just a number multiplied by a matrix, all you do is you would multiply the 4 to every single element, like this. You keep going and it won't look, it'll be, every single thing gets multiplied by 4. Alright, now but when you're multiplying two matrices together, you have to follow certain rules. So, the thing is, it'll be, so, if we say, let's say, we call, so, AB 1, 1. So the output of, you know what, we'll call, E equals AB. So E11 would be the first row, first column of E would be this row multiplied by this column. And what that means is this will equal -1 times 0 plus -3 times 1. So we do this one times this one plus this one times this one will give us E11. Alright, now E12 would just be very similar. You always, this one corresponds to the first one. That's the row, and then this one corresponds to the column. Just like that. So now E12 would be -1 times 1 plus -3 times -3. Alright, and now say we wanted E 3 3. Okay, so, or no, 3 2. So third one of the first one and second one of the second matrix. So that'll be 2 times 1 plus 2 times -3. Just like that. Alright? Now, you would do that for all the terms, so it's a lot of work. Now on the test it's not expecting you to do all that work. So the question is going to be something more along the lines of this. The matrices A, B, and C are given. So the equation, kind of like we had before, D equals AB minus 2C. But instead of finding the entire matrix, we just have to find that just this particular component of D. So now, if we know AB, it's AB minus 2C, we can say that D23 equals, and we call this again E, it's going to equal E2, 3 minus 2C2, 3, because that's how we add and subtract matrices. So now we just have to find E23. We already know what C23 is, and we just plug in chuck. So E23, remember, first one pertains to the first one, first little number subscript. So it's second row multiplied by the third column, just like that. So it's going to be -2 times -1 plus -3 times -3. So this ends up giving us E23 is going to be 2 plus 9 is 11. So then D2, 3 is going to be 11 minus 2. Now C23, so row 2, column 3, it's that one, -2, and that's going to be 15. So it's pretty straightforward as long as you understand how to do matrix multiplication, and the shortcut, I guess, to being able to just solve for one element of that matrix. Lastly, for this video, we're going to go over inverse matrices and inverse and determinants. Now, given this 3x3 matrix, finding the determinant. Now, I don't know if you remember in calculus we did the cross product of things. So the cross product is where you kind of looked at this one and kind of ignored this, and then did this minus this. We're kind of gonna go over it again. So the determinant of A is gonna look something along the lines of 2. So this guy, like I said, we kind of ignore this thing, and we'll do the Wronskian of this leftover square. So the Wronskian of that is 0 times 2 minus negative 1 times negative 2. Okay, so that's what we do for that first term. Now for the second term, we look at 1, cross out what's underneath, and then do the Wronskian of this leftover bottom part. Now the second term is always minus, so it's going to be minus 1 times negative 1 times 2 minus negative 1 times 1. Now, similarly, the third one is just going to be this term, scribble the 1 underneath, and do the Wronskian of the leftover stuff. Underneath, it's going to be plus 2 times negative 1 times negative 2 plus 0 times 1. Now, excuse me for getting kind of off there. We're gonna gotta make this a little smaller. Sweet. So now that's our determinant. So if we simplify, it's gonna be 2 times, this is 0, it's going to be a positive 2, so it's going to be a minus a positive, it's going to be a negative, so it's going to be negative 4, negative 1 times, this is going to be a negative 2, plus 1, it's going to be a negative 1 times negative 1 is a positive 1, and here we're going to left with negative 1 times 2 is a 2, technically it should be a minus, but since there's a 0 there, it won't matter, so this will equal 1. So determinant of A is 1 in this case. Now, it's just like the cross product. If you remember how to do the cross product, the only difference is instead of having an I, J, K, we actually have numbers there. So if you're confused, you can always go back to that. Now the inverse is a little bit trickier in that we have to do more stuff. So you're going to write your matrix. Sorry, negative 1. And next to that matrix, you're going to write an identity matrix of the same size. So in this case, it'll look just like this. An identity matrix is just 1s across the diagonals, zeros everywhere else. Now, what you do to the left matrix, you do to the right matrix. Okay, they're connected at the hip right now, as soon as you do this. And now, you're going to try and make the left matrix look like an identity matrix. So you want it to look like 1s across the diagonals and zeros everywhere else. So, for me, I think, look, this one's already 1, so let's move that to the top. We're going to kind of go like row epsilon. So we're going to just switch these two. We're left with 1, negative 2, 2. Remember, what you do to one side, you do the other. So now this is row 1 on the right. And negative 1, 0, negative 1, 0, 1, 0. And then this is going to, since we switch, it's going to be 2, 1, 2, 1, 0, 0. And now we want these two. The easiest way is to make these two 0. So we're going to do row 1 plus row 2 equals row 2. Now we're putting our big pants on, so now we're going to also make the other one 0, so it's going to be negative 2 row 1 plus row 3 equals row 3. So we're going to do two operations at once. Just keep in mind, so that's what we're going to be doing. So row 1 plus row 2. 1 plus a negative 1 is 0. So hold on, let's rewrite our first row. Rewrite our first row, and now, oh sorry, should not have rewritten everything because we haven't finished. We're going to do multiplication and stuff to it, so don't do that. So now, row 1 plus row 2. So 1 plus a negative 1 is 0, negative 2 plus a 0 is negative 2, 2 plus a negative 1 is 1, and now we got to go to another row. So 0 plus a 0 is 0, 0 plus a 1 is 1, and 1 plus a 0 is 1. And now we'll do the other one. So negative 2 row 1 plus row 3. So negative 2 plus 2 is 0. 4 plus 1 is 5. And negative 4 plus 2 is negative 2. And then it's going to be 0 plus 1 is 1. 0 plus 0 is 0. And negative 2 plus 0 is negative 2. Alright, so now we have both of these zeros, check mark. Now we want one of these to have a 1 here and the other ones to be a 0. Now if you see, to make one of these to be a 1, the easiest thing to do would be 2 row 2 plus row 3 equals row 3. Alright, so we're going to do 2 row 2 plus row 3 equals row 3 because that'll make this a 1. It's easier than trying to divide by negative 2 to get fractions. That's also possible. You will get the same answer. It just won't be as pretty a way of getting there. So 0, negative 2, 1, 0, 1, 1. Now we'll go to, 0 plus 0 is 0, negative 4 plus 2, 5 is 1, 2 plus a negative 2 is 0, 0 plus a 1 is 1, 2 plus a 0 is 2, and then 2 plus a negative 2 is 0. Alright, so from here, this is a 1, so we want to switch these two rows pretty much. 1, negative 2, 2, 0, 1, 0, 0, negative 2, 1. Now keep in mind, you have to make sure that you're switching these rows too. So 1, 2, 0, and 0, 1, 1. Finally, well, almost there, we're going to make this a 0. So we're going to do R2 plus R3 equals R3. So you get 1, negative 2, 2, 0, 1, 0, 0, 1, 1, 2, 0. Okay. So 0 plus a 0 is 0, 2 plus a negative 2 is 0, 0 plus a 1 is 1, 2 plus a 0 is 2, 4 plus a 1 is 5, 0 plus a 1 is 1. So now we need this to be 0 and this to be 0. So we're going to do kind of the opposite, like go back, right to left now. So to make this 0, we'll use R3, row 3. To make this 0, we'll use row 2. So we'll do negative 2 row 3 plus row 1. And we can do two operations here. And we can also do plus 2 row 2. That's possible, and that equals row 1. So that'll cancel out both of these terms. So now we'll go 1 plus a 0 plus a 0. Awesome. This is a 0 plus a negative 2 plus a 2 is 0. Negative 2 plus 2 is 0. So that's what we want. Now we have the matrix that we want. Now we gotta make sure we do the right thing here. So it's gonna be negative 4 plus 1. Sorry. It's gonna be negative 2 row 3. So negative 4 plus row 1 plus 0 plus 2 is gonna be negative 2. And now the next one is going to be negative 10 plus 0 plus 4 is going to be negative 6. And negative 2 plus 1 is negative 1. 1, 2, 0, 2, 5, 1. And this is your inverse. That answer. Alright, so that's a little complicated, it takes a lot of time, but you'll probably be tested on a 2x2 matrix, and there's kind of a trick to getting it. So let's say you have a 2x2, and it's A, B, C, D, where those are numbers, okay? The A inverse is going to be 1 over the determinant of A times by you switch these columns and you negative the other column. That is the determinant of A. the inverse of a 2 by 2. So very, very simple, very cool. We can do this very easily. So the determinant of A is going to be 1 over, and it's going to be 3 minus an 8, negative 8, it's going to be 3 plus 8 is 11, and then we just switch these two. We're going to be left with 3 up here, a 1 down here, and negative 4 and a 2. So this is our inverse. Usually they'll probably ask you for like A inverse 1, 2 or something like that. So that would be this one, right? Row 1, column 2, so you'd say negative 4. This would be negative 4 over 11. Don't forget to divide by the determinant, but as you can see, it's a lot simpler than doing a 3 by 3 if you see how to do this. Now you could do it the other way, where you put the that matrix next to it and do what we did with the other one. It's a lot faster than 3 by 3, but this is literally the fastest way. It's just knowing